Hi there, everybody. Thanks once again for checking out another math video. This one is called the opposite side, opposite angle principle. Well, that's what I'm calling it anyway. Honestly, I can't find a lot of agreement in the literature what the name of this idea is, or even if it's a conjecture or a theorem, or what the heck kind of classification this idea would fall into. So I'm just calling it the opposite side, opposite angle principle. And I know some people call it that, but it's called other things by different people. Anyway, this is the second of two videos that I've made about triangles recently. The first one was about the triangle inequality theorem. So I hope you have a chance to watch that one also. All right, so this principle says the following, that in any triangle, the longest side is always opposite the largest angle. Sounds like a kind of intuitive idea. I mean, if you think about a picture of a triangle that has one big angle in it like that, that big angle is always going to be on the opposite side of the triangle from the longest side of that triangle. And that's all this theorem says, or principle, or conjecture, or whatever that is. That's all it says, which doesn't seem like much, right? But it actually has a lot of other kind of implications for us. And I wanted to explore those in this video with you. For example, one of them is that if the largest angle is always opposite the longest side, then the shortest side is always opposite the smallest angle. Okay? Well, that's true, in fact. All right? It also means that the mid-sized side is always opposite the mid-sized angle, but I didn't put that in here because it's kind of wordy and kind of unnecessary. But one other thing that's really important from this principle that we get is this, that congruent sides are always opposite congruent angles. Now that is really cool. That's what we're talking about when we talk about isosceles triangles, right? So this opposite angle, opposite side principle is kind of the explanation for why isosceles triangles are the way they are. And so I wanted to explore that a little bit with you in this video. First off, I put up here a picture of three different triangles just to kind of get so that you can kind of look at these triangles. These triangles all have measured sides and measured angles. And so just compare them. Like, let's look at that first triangle there. That is a scalene triangle, isn't it? Where all three sides are different and all three angles are different. Well, that's kind of cool, that just to know that if all three angles are different lengths, then all three angles are different measurements. Okay, so that's kind of a conclusion that we can draw about scalene triangles. The other two triangles are both isosceles triangles, and I put them both in there. One of them is acute, and the other one is an obtuse isosceles triangle, just to show you that that really doesn't matter. That the longest side could be opposite the largest angle like the bottom one there, or the longest sides could be congruent sides and opposite congruent angles. Okay, so you can see that's where we get isosceles triangles is from this idea here. And by the way, I drew these triangles with this really cool program called GeoGebra. So I just want to say thanks, GeoGebra. It's a really great app for your devices, or a website, or app for your computer. A lot of really good exploration can be done on GeoGebra, so I really like it. Anyway, let's take a look at one of the kinds of problems that you'll be asked to explore. So here's a triangle. It's not drawn to scale. I've got angles labeled and I've got sides labeled. And the question is this triangle even possible? Much like we were looking at the triangle inequality theorem, this is kind of a basic question. Could you make a triangle with all of these measurements in it? All right, so let's look at this in the context of this opposite side, opposite angle principle here. Look at the smallest angle, 40 degrees. It's opposite the shortest side. And you can see that when you match up angles to the opposite side, that they do kind of all correlate here. The largest angle is opposite the longest side. The mid-sized angle is opposite the mid-sized side. And so according to that this triangle appears to be a possible triangle. Just a word of note here. Actually, it's a lot more complicated than this. And as you go through your study of mathematics, you will learn some other tools in the realm of trigonometry that will allow you to verify precisely whether or not this triangle is possible. But at least it seems to correlate with the largest side, largest angle principle here. And we would have to conclude that based on this, that these correlations here tell us that this triangle is possible. Okay, let's look at another one, something else like this. So here again, a triangle, three sides labeled, three angles measured or labeled, and is this triangle possible? You can see that the smallest angle is in fact opposite the shortest side, which is good. But when you start looking at the other pairs of sides, we have a problem here, right? The 80 degrees is the largest angle, but it's not opposite the longest side. All right, and 13 is the longest side, but it's not opposite the largest angle. So we would have to say that this triangle, as drawn, is not possible. Okay, so that's one of that's one of the things that you're going to use this for, is just to say whether or not a triangle could even be possible. All right, and one other thing that you're going to do is something like this. All right, let's say you've got another triangle. It's not drawn to scale. It's got angles measured but no side lengths. And what I want you to be able to do is to list the sides of this triangle in order from shortest to longest. All right. Now, what I want to say here is that you cannot trust just the drawing itself to do this. You have to look at the numbers. For example, there's your 34 degrees. That's the smallest angle in this triangle. It's opposite the side labeled AB. So that AB must be the shortest side of the triangle. All right. It doesn't look like it's the shortest side, but if according to those numbers, AB is the shortest side. The next biggest side is opposite the next biggest angle, 36 degrees. And then the third side, AC, must be the longest side because it's opposite the largest angle. Okay, well, there you go. That's the opposite side, opposite angle principle. And I hope this video was illustrative for you. It's a fairly straightforward idea, but it's one that you got to think about. Okay? All right. Well, thanks again for watching this video, watching both videos, I hope. And I hope you're doing well. I hope to see you real soon, too. Okay? Bye-bye.